We all come to the electric universe because of patterns. For some of it's patterns of repeated catastrophe told over and over again in mythology around the world. For me, it was patterns in the rocks, the squatter man, and an explanation from Dave Talbot and Anthony Peratt for a physical reason for why they're there. For others, it's patterns in nature. We see fractal patterns everywhere. Everywhere there's motion and energy, in living things and in inanimate things too. Look at a cloud that looks like a feather, and you wonder if it's just random wind motions that can do that. These patterns appear where rivers cut through rocks. We see it in living trees, plant life. But when we look at nature in its raw form, when an electric field of 1,000,000 volts rips atoms apart to create lightning, we can see underlying these patterns, it's electric. These patterns are the true symmetry of nature. If we ask consensus scientists, they say, well, it's just magical organization from chaos. But we know there's an underlying truth. We know that these patterns form a signpost for us that we can follow, and that behind them, there's an electrical model underlying the physics. So what I'm going to present is an electrical model for Earth, and I'm going to tell you what I think happened to cause the continents to form the way they did. Now, when I look at Earth, I don't look at it as the little blue ball that we're standing on. I look at it as this electromagnetic field, and the blue marble inside is just one component to an electrical circuit. And using these fractal patterns as a guidepost, I feel we can look at other electromagnetic planets and bodies in the solar system like the Sun and Jupiter as analogies for Earth and look for comparisons. So that's what I'm going to do in my presentation. That's the guidepost I follow. So electric models for Earth have been around since Christian Birkeland and his Torella experiments. And recently, Richard Moore made a presentation in Space News and talked about the possibility that Earth is an electromagnet and its rotation is a motor. In 2015, Bruce Laybourne came and gave a presentation on Giovanni Gregori's hoop theory. And Giovanni Gregori's hoop theory says that electrical currents follow the magnetic hoops that we see in the electromagnetic field, and that these currents affect earthquakes and volcanoes. Now, I don't particularly adhere to everything in Gregori's theory, but as far as these hoops are concerned, that's what I want to talk about. I tend to agree with him. Some of what he says about the cause and effect and the material structure internal to the Earth, I have some differences about. Excuse me. Come back here. Bruce and I got together last year after the conference because Gregori's theory seemed to support my own work on arc blast. Now, arc blast is a theory for mountain formation, where supersonic winds are drifting mountains like sand dunes, and the shock waves formed by those winds are creating triangular buttress features. And if you look at these triangular buttress features, they form in wave patterns, and that's what I demonstrated in my talk last year. But it required an electrical event coming from internal to the Earth, a dielectric breakdown of the crust that arced across the continents to form these arc blasts. And Gregori's theory and his hoop theory seemed to provide that. So we got together to see if we could dovetail his theories with my arc blast theories and see if there was a connection. Another thing that Bruce described in his discussion in 2015 was the fact that hotspots form on the Earth at triple junctions, what he called triple junctions. And he said we can see these currents beneath the Earth where the plate boundaries exist. So for instance, here in this heat flow map, we can see where the Earth is hot, and it also corresponds to where the crust is thinnest at the plate boundaries. And he says these triple junctions, where there's branches in the plates, form hot spots. Let me see if I can get. Well, over here on the left, the red blob is the Eastern Pacific Rise. And as you can see, where it reaches the top of South America, there's one of these triple junctions. And what Bruce described is that that triple junction has a connection to the electrical events at Lake Maracaibo, for instance. Now, this is another projection that shows these currents better. You can see that they sort of zigzag up and down around the Southern Ocean, encircling Antarctica. And then at the nodes, they rise up north and spiral around the Earth like seams on a baseball. But they get stopped at the continents. So on the left, you have a current that flows up into Africa, into Europe. And then in the center, it flows up. There's a current flowing up to Australia and China. And then you have another current flowing up to North and South America. And then the mid-Atlantic ridge goes up and wraps all the way over the North Pole and comes back down into Siberia. Now, if we look at the continents and how they're formed, they're these cratons that are the thickest part of the crust. And the cratons are shown in these diagrams as the pink and orange blobs. And then surrounding those areas, there are the orogenic belts in blue. And the orogenic belts are sediments that are deposited, and on top of those are the mountain arcs. And then the yellow features are igneous extrusions that extend the continental plates. Another feature of triple junctions are these deep sea trenches. Here's the Puerto Rican and Cayman Trench, and it makes a big hook feature between North and South America. Below South America, there's a similar hook trench at the South Sandwich Trench. It's called the Scotia Anomaly. So if we look at this pattern of trenches and continents, they sort of follow a spherical harmonic pattern. Now, these are all spherical harmonics that I'm showing, and they form at different resonant frequencies. And the one I've circled is the one that matches the Earth's pattern of continents and trenches. If you consider that the trenches are cathodes and the continents are anodes, then that spherical harmonic shows that the Earth is divided into 4 quadrants, both longitudinally and laterally. Now here's another image, and this one shows the currents spiraling up like baseball seams. And down on the lower right, you can see the circumpolar current circling all the way around Antarctica. And you can see the mid-Atlantic ridge, how it rises up over the pole, comes back down into the craton at Siberia. So this is my model of the Earth interior. We have the polar induction. And as Dr. Scott described the other day, that polar induction from the aurora is actually a coaxial current that's counter-rotating currents. And so inside the Earth, what I'm saying is that it also forms a coaxial current. And there's a core current that wraps around the Earth's core and it forms an electromagnet. But then there's a secondary current induced that comes down through the Earth's mantle. And this mantle current forms these hoops. Now the hoops are controlled by the resistance in that mantle current. And when the resistance goes up, it forces more current out through the hoops. And then the hoops go through the capacitive layers of the Earth's crust and the atmosphere, and then back through again. And it's the dielectric properties of the crust and the capacitance in the crust and the atmosphere that governs our weather and our climate, and it also governs geology. So I'm going to talk specifically about North America from now on, and I've laid it on its side to better visualize what's going to happen. So here again is the model of the Earth, and you have the core current wrapping through, and then the mantle current, which follows the interface between the mantle and the crust. And along that interface, and between that current and the inner current, there's an electric field. And then between the mantle current and the magnetosphere, there's another electric field, and they're in opposition, and they're trying to maintain a balance at Earth's crust. Now, in a Velikovsky-style electrical event, whatever the causation, whether it's Venus or a solar flare, and some external perturbation to the electrical balance here, what would happen is that these currents, internal and outer mantle current, will push apart and pull together. There's Lorentz force that's going to occur. And if they push out, then they push out into the crust. So what I'm proposing is that these currents get pushed out into the crust and melted, creating large shield volcanoes. And that essentially is what forms the cratons that underlie the continents. Now you can see how this would happen if we have something out here in space, a big solar flare or some cometary body coming nearby. It's going to amp up the magnetosphere and induce more current internal to the Earth. And that's what's going to cause these fluctuations between the mantle current and the core current. So then after the craton is formed, the current now is meeting more resistance because it's hitting this mantle and it's more resistive and it now has to find new paths. So it seeks a path around the craton and erupts. And in North America, that eruption we see at Yellowstone and at the supervolcanic fields in northern Arizona along the Mogollon Rim. So what I'm saying is that there are coronal loops, the hoop theory of Grigori, but they're coronal loops that form, and they jump from the cathodes in the trenches to the anodes at these supervolcanoes that are forming. And then they drag winds and oceans, tidal waves of oceans across the land that form the orogenic belts and form the mountain arcs. Now, when I say coronal loops, I'm talking about exactly the same thing that's on the sun. And if you look at the picture on the right, those are coronal loops on the sun. They form around the sunspots. And if you look at them, you can see that these coronal loops are repeating fractal patterns. Inside the big loops, there's a bunch of loops that march across the photosphere. They're chaotic, but they're also organized. They're fractal forms. So Bruce and I went to Utah to investigate this idea last summer after the conference. And here we are with Larry White standing in front of the San Rafael Reef. We were looking at the arc blast features on the reef at the time. So the evidence we found was substantial. I can show hundreds of examples in photographs and Google Earth images, but I'm not going to have time for that today. I'm going to have to just kind of skim over the big picture. So what happens is this, according to my theory. The purple ring is the coronal loop, and it dives from the interior of the Earth out through the atmosphere. And this, along here, means this is the surface of the Earth. And as this coronal loop forms, its electromagnetic field in the atmosphere is ripping atoms apart and creating plasma storm cells. And that's what these toruses in yellow and green represent. These storm cells are like storm cells we see today, and they're analogous to sunspots on the sun. But in Earth's atmosphere, which isn't a hot plasma atmosphere like the sun, there are different things that go on. So this current circulates, the simplest form of current, and it's driven by these coronal storms because they have a difference in potential. And this current drags winds with it, and they go up around the loop and back down. And these are supersonic jet streams. And when it comes down, it forms a crater. So what we see are the footprints of domes and craters. As the winds loop up, they deposit layers and layers of sediments that form domes and plateaus. And then as it comes back down the other side of the loop, it crashes into the ground, forming a crater. And on the crater, there's triangular buttresses that are pointing outward because the supersonic wind formed a shock wave that molded those into the ground. And on the updraft dome, you have triangular buttresses pointing inward all around the rim of the dome by a supersonic shock wave for the same effect. So you have craters and domes, and the wind directions pointed by the triangular buttresses. This is the San Rafael Swell in Utah. Now, the San Rafael Swell is this feature up here, and you can see it's a D-shaped structure, and it's layers of sediments that are piled up into a dome. All along the face of it is the San Rafael Reef, and it's a monocline of triangular buttresses. Inside the dome, there are canyon lands with a flat floor and vertical walls to the mesas. This region is etched away. EDM, electrodynamic machining, sputtering arcs that were formed by these coronal clouds that ate away the land, pulling whole mountains of mass of land away at a time. Now notice over here is a mirror image, and this is the crater. This mirror image feature has a straight backside and a semicircular front. It's a D-shaped. Put together, these two form butterfly wings, almost perfect butterfly wings. Now, the front of this crater is formed by the Colorado River and one of its tributaries. And in the center here of the crater, there's a mountain. This mountain is a fulgurite, or actually a series of fulgurites, where lightning strike. There was cloud-to-ground lightning from the coronal storm. And this is typical of the craters. We find fulgurites in the center, and they're ringed by a river. And that's because the crater, as it forms, is a negative charged feature. And the arc blast that comes is repulsed by it and skirts around. But the positive dome doesn't have that, and it's ringed by the triangular buttresses. And in fact, the San Rafael Swell wraps around here, and then there's Capitol Reef behind, and it's another monocline of triangular buttresses that point outward from the crater. And between these two, they form an S-shaped curve. It's almost a continuous mountain range. Now I want to direct your attention to the little circle in the middle. That's the feature I'm going to show you next. And by the way, the San Rafael swell is 70 miles across, and so is the crater. So a total of 140 miles stretch across this picture. This is what's inside that circle. It's another perfect set of butterfly wings. This is the updraft dome here, and all along its edge is a monocline of triangular buttresses formed by wind. This is the crater, and it's now a dry lake, and all along its ring are outward pointing triangular buttresses. In between here we have Fulgurites. These dark patches are lightning strikes. Now this is the rim of that dome, and this shows the triangular buttresses. And actually there's 4 ridges formed. One here, and the inner ridge is smooth. It doesn't have triangular buttresses, but it's a smooth dune-shaped feature. And then in the center, there's 2 more ridges, which do have triangular buttresses on them, indicating a shock pattern. And then the outside rim is here, and it's also smooth. So what this indicates is that the winds that were forming this dome started out at subsonic speeds, then rose to Mach level, and then back down to subsonic speeds again. And during the Mach phase, it created the shock features. This is another dome. Now this dome sits right on the edge of the San Rafael swell. And again, it has a D-shaped pattern to it with triangular buttresses pointing inward all along here. Is my finger working? And all along this rim. And in the center is etched away a canyon. And if you look closely at this, there's no significant rivers or creeks that could have eroded this way by water. Now, stepping back to a higher view, circled here is that same feature. This is the dome. The San Rafael swell is right inside here, and on the other edge of it over here is a crater. It's approximately the same size as the dome, and it has triangular features pointing outwards. So this is a close-up view of it. So you have a crater and a dome on either side of the San Rafael swell. You have inside the wings of the swell and its companion crater another little tiny set. And that little tiny set was 7 miles long. So it's fully 1 order of magnitude smaller than the big footprint of a coronal loop. So what you have here is loops within loops, nested fractal forms within nested fractal forms. It's like those Russian dolls that are kind of annoying. You open one up, and there's another one, and you open it, and there's another one. That's how these things form. So this is another view from the top down of the San Rafael swell. It's a D-shaped lobe right here, and then this is its companion crater right here. Perfect butterfly wings. Now this is an image of Monument Valley. Monument Valley is another dome formed right here. Along its southeastern face is the Combe Ridge monocline, and it's another set of triangular buttresses. Inside the dome, it's almost completely etched away, only leaving the spires and monuments that we know from John Wayne movies. Then right next to it over here, not quite a mirror image in butterfly wings form, but it is abutting to it and right next to it. The San Juan River forms a semicircular arc defining the outside of a crater. And inside the crater right here is Pastora Mountain, and it's another set of fulgurite-formed mountains. So you get this repeating fractal form again. The mountains inside the crater, the dome, which is etched away, and the monocline defining the edges of it and showing the wind directions. This is San Luis Valley in Colorado. Now this is a downdraft crater, and its interior is at 7,000 foot elevation, a nice flat floor, and all around it are 12,000 foot peaks with triangular buttresses plastered across the sides of them. And inside here, you have Fulgurites, lightning strikes. So if you map out these updraft domes and downdraft craters across the Colorado Plateau, they start forming sort of an image. And if you map also the direction of wind by looking at the monoclines and the angle of the triangular buttresses, you get a wind pattern. So what I see is winds coming in from the south and wrapping around in a counterclockwise rotation. And the winds thread through the updrafts and back down the downdrafts like laces, like threading shoelaces through a shoe, up and down through updrafts and downdrafts. Now, if you keep mapping all over the Colorado Plateau, you find these footprints all over the place, and they're overlapping. And you see there's sort of a time dimension, or a sequence of occurrence. Some footprints overlap others. But if you look at the overall pattern, you see it's the same pattern of the dome itself, because it's a larger fractal expression of a dome. It has a D shape, and on either side of it are the volcanoes. There's Yellowstone up here, and these are the volcanoes of the Mogollon Rim. So they straddle the Colorado Plateau, and all these updraft and downdraft domes form inside that. Now the red features I've shown here are the wind ridges, and I've mapped them, and the little hash mark shows wind direction. So by doing that, I was able to do a wind map for the entire continent, or the orogenic belt portion of the North America. And what it shows is that there's two inflowing winds, one from the south and one from the north. And they come in and they wrap around in a counterclockwise multiple vortex system. So the first wind comes from Mexico, and it comes in and it wraps around counterclockwise over the Colorado Plateau. Then this wind comes in from Alaska and pushes its way in around the arc of the mountains of the Sierra Nevada, and then wraps around in a counterclockwise fashion in a vortex centered over Salt Lake City. And then there's a third inflow that comes in, wrapping around from the east, and flows over Wyoming and Montana. And then in between, there's this red line, which is a ridge. It's a pressure ridge for the shear zone between these three vortexes. And it forms this S shape, and then it shoots out a tendril here between this Montana jet stream and the Colorado Plateau jet stream. Then there's a fourth jet stream that's just forming. It comes in over the LA basin over here from the west, and then it wraps into the rotation over the Mojave Desert. Now looking at the southern inflowing winds, this jet stream comes up from the Caribbean, and it flows up through Mexico, pushing mountains aside. You have the Sierra Madre and Sierra Occidental. And then it comes in and it wraps around counterclockwise over the plateau. Now this wind dragged a tsunami with it, and the water, shown in dark blue, came up and it wrapped around over Texas and then poured back into the Gulf of Mexico. And this is where it poured back into the Gulf of Mexico. All of this feature is a bunch of mounds and divots from the turbulent water as it poured sediments in and churned them up on the seafloor. Geologists have wondered about these features forever. And this is a close-up view of these divots in the seafloor. Now this is in the Canadian Arctic, and this land is not underwater, but it once was. because it has the same landform of mounds and divots and channels cut through it from water pouring down. Now this is the northern jet stream coming from Alaska, and it did the same thing. It formed this channel, pushing mountains aside to either side. And along the west, you have the Cascade and Sierra Range, so the whole volcanic strip along this magma current below erupted volcanoes all along the Ring of Fire, and those helped support the wind as it blew that drifted against it to form the Sierra Mountain Arc. Now the jet stream's main attractor was Yellowstone right here. So it came down and circled around, forming a Great Basin, aimed directly at Yellowstone. And then another jet stream came around and circled around into a vortex, rippling the land and forming the basin and rain regions across Nevada. And with it, it also brought, in the dark blue, a tsunami of water. And this water followed the same path. First, it curled around, forming the scablands in Washington state. And then it followed the Great Basin up towards Yellowstone, and then shot out across the plains of Nebraska. And then another flood came and followed this jet stream. And as it curled around into the hot vortex, it began to evaporate. And that's where you get the Bonneville Salt Flats and Salt Lake. And behind all these basin and range mountains, there's alkaline lakes too, as this water evaporated away. Now these are the scablands in Nebraska where the water shot out over the plains and formed these ripples and dunes. Now if you look at the North Platte River right here, the scablands that I just showed you are just north of it. And this is where the water flowed out across Wyoming, out into Nebraska, and then collected into the North Platte. And what you'll notice about the North Platte is it's almost a straight channel. And when water erodes its own path, that's what happens. You just get a straight channel, not a Lichtenberg figure. And that's why it looks so much different from like the rivers down here that have your typical Lichtenberg branching. Now this is the eastern jet stream that came in over Montana and Wyoming. And it too curled around, seeking Yellowstone, the main attractor, the big anode. And it too wound its way like shoestring through laces, through updraft domes and downdraft craters. This is the Yellowstone Dome itself, and this is the crater right next to it. And then near Rock Springs, Wyoming, you have another updraft dome right here with a D shape, and then you have a downdraft crater. Now this was an area where the waters washed through, so it was modified heavily and eroded by that tidal wave that washed through. And this downdraft dome is somewhat polygonal in shape, and I suspect that's because the winds were pushing it up against the shear zone with the other multiple vortex over the Colorado Plateau. So I've talked about Fulgurites and Fulgurites. So I want to show you a little bit about how I think they were formed. First of all, a Fulgurite, I believe, is formed by a negative arc, a cloud-to-ground lightning bolt. And what it does is, because it's a negative arc, it has a return stroke from the ground that draws anodic material to it. So winds pull in, pulling dust, and that dust forms a dome. So you get, first it forms a shallow crater, but then this dust piles in and it starts to form like a pancake dome, and then that grows up into a mesa, and then that grows up into, ultimately to a mountain. And all along the sides, because of the shock features of supersonic winds of this pulling in, it forms triangular buttresses. So a Fulgurite is really like a mini updraft dome. Now a Fulgurite is like shiprock. You've all seen shiprock. Shiprock is a solid spire, but it's the sheath on the outside, and in the middle there's this brown, black, boiled-looking mud that's coming out. Take a look at it sometime. I don't have any pictures of it, but it's pretty easy to see that there's a hardened sheath, and inside there's this boiled mud-looking stuff that's come out. And then shooting out around the base of, I think something's fallen off here. Can I get a hand? I think my headgear is falling off. Help? There, maybe I've got it back. I think I've got it back. Can you all hear me okay? Okay, sorry about that. Slipped off the back of my neck. So a fulgurite has these dikes that emanate out in a star pattern from it. And they're made of the same stuff that's in the center of the fulgurite. It's called minette, at least in the Four Corners region where you look at, can see these things like shiprock. It's called minette. And what it is a highly alkaline rock. It's a very potassic rock. But it's really no different than the country rock around it, except that it's been sucked of all of its electrons. So what happens to form these dikes is it wants electrons from the ground. Positive ionic material lays over the ground and forms winds in the fulgurite. This is drawing from underneath the ground because you've got the double layer. And so it just sucks up the ground to it and fuses it together into a wall that forms a dike. Now this is the Wind River Range, and this is formed by a fulgurite that struck up here and formed a dike. And then the supersonic wind, the jet stream, carried dust that piled against it, and that's what formed this mountain lobe. And all along this side, on the northern side where the jet stream hit, you have triangular buttresses form. They're not on the back side. This is another mountain lobe formed, the Uinta Range, very similarly. And it's another fulgurite and dike formation that the wind piled against. And that formed the mountain range. And that's why we get these funny-looking mountain lobes. It's another fractal form. Now, I talked about surface conductive arcs, and they play a big role in sculpting the landscape. And what they are arcs that come out of the trenches, and they come over the continents and follow the potential gradient towards the main attractors, which were those supervolcanoes. So this shows the continental United States and all of the watersheds, and you can see they're all fractal formed river systems. And this is the Colorado River that comes up from the Gulf of Mexico, and it's heading for Yellowstone and for northern Arizona. And it forms the leaf-shaped pattern that we see over the Colorado Plateau of a dome. So most people are taught and they grow up learning that water just seeks its own path, and that's what causes rivers. But geologists know that rivers follow fault lines. So the water didn't come first, it's the fault that came first. And it was these surface conductive arcs that formed the faults. So this represents a surface conductive fault. And where you have a canyon, like say the Grand Canyon, it's going to follow its conductive path through the earth and blast the overburden away. And it's going to leave a fault below it. And then it'll shoot out tendrils that might follow, say, a wet limestone layer that will blast outward and form stubby box canyons laterally from the main canyon. And occasionally, these filaments will continue through the ground and erupt up through it, not blasting away the overburden, but instead forming karsts and breccia pipes. Now, all along the southern rim of the Grand Canyon are these breccia pipes, and they shoot up out of the ground. Miners look for these things. They look for them using magnetometers because they have a dipolar magnetic signature. And the reason they look for them is because these breccia pipes are hourglass shaped. And down in the narrow neck of that hourglass, they find uranium and precious metals. This is what a surface conductive arc would look like. This is on the sun, so this is an analogy. But it's a surface conducted river of fire. And that's what we're talking about when I say arc blast. Now, stepping back and looking at the big picture again, and looking at the wind patterns, there's this feature here, which is an S-shaped curve. That's the shear zone between these multiple vortices. Now, just taking a look at it, does it look like anything else similar somewhere else in the solar system? Like the Great Red Spot of Jupiter. It also has two inflowing winds, counterflowing winds, that circle around and form a giant oval storm system. And when we first started looking at it, it was a big oval and there were two inflowing winds, opposing winds, unipolar winds. But over the years, it's contracted and gotten smaller. And as it got smaller, this new filament of wind started coming in from the top. And the Great Red Spot took on a triangular sort of shape, like this. Just like the winds that come in from Montana and Wyoming in the wind map that I just showed you. So remember, there was also in my wind map the beginning of a wind coming in from the west over the LA basin. So somebody can call NASA and tell them that if this continues to contract, this fractal form is going to form a diamond eventually. So if the Great Red Spot is truly a fractal form that has the same electrical mechanisms going on in it that what formed the Colorado Plateau on Earth, then what we should see are some coronal loops in the Great Red Spot. So take a look under this white shelf cloud at these Roman arches. These are the coronal loops. Now this photo is a NASA photo that's been colorized to give better contrast, but otherwise it's a real photo. Now these are the coronal loops arching almost like a Roman aqueduct here, and then above them another set of arches. And what you see here is a pillar cloud that arches both ways, and that arch, that loop, dives into a toroidal mesocyclone over here and over here. Looks like a donut that it's diving into. And you get the same thing up here. It's arching out of here into a big donut, arching out of here into a big donut. So you have updrafts and downdrafts connected by loops. These are coronal loops, just like you see on the sun, only it's not the ray gun hot plasma atmosphere that's on the sun, but a hydrodynamic atmosphere. But the hydrodynamics is electrical at its core. Temperatures and pressures are electrical fundamentally. You can also see that there's a larger form of looping jet stream that comes in to a counterclockwise circulation here. So this is a repetition of the fractal form. Another fractal feature of the Great Red Spot is the filament that divides these vortices. And it's just like the mountain range that extends from the Tetons down to the Mogollon Rim. It's an S-shaped curve that shoots out a tendril as this third rotation begins. Now, I call this the Steinbacher-Yelverton curve. I thought you'd like that. Also because it's an S and a Y, SY curve. But Michael and Billy did an experiment where they set up a plate electrode with a dielectric material over it, and then 2 other electrodes, and set up an electrical circuit with an air gap. And it blew winds that formed a formation just like this. And so they were right on to the right thing, looking at the formation of a coronal loop experimentally. And everything I'm talking about here can be done experimentally, I believe. Now, I don't want to belabor the point, but our weather today, we can see these same things going on. This is a supercell thunderstorm. And what it is a rising current and then a downdraft of rain current. Now, Dr. Pollack talked the other day about how rain doesn't just condense and then fall from the sky. It's being pulled from the sky. And he's exactly right. That's what's happening. This is a coronal loop. And the rain curtain is the downdraft. But it's, recombined material, so it's not very electrical anymore. It just falls down. But these storms are formed by a corona at the base and then a corona in the anvil. And they spit positive lightning from the anvil and negative cloud-to-ground lightning from the lower corona. And these form winds that are unipolar winds, that are downburst winds and updraft winds. All the same features that we're talking about on the sun can be, in coronal loops, can be seen right here. And in fact, on the sun, you see thermodynamic effects too. There's a layer of neon and then a layer of iron plasma. And as these coronal loops go through those, there's a thermal electric effect. And that's what we have here, is a thermal electric effect. I call this a thermopile. And another feature on sunspots is a violent downdraft beneath them. And this is a tornado, which is just another fractal repetition of the same electrical mechanism. So you have updrafts and downdrafts within updrafts and downdrafts, loops within loops, and vortices within vortices. And everything I'm talking about can be done in a lab. I got this from a chemistry book, and this is a point electrode up here over a plate electrode. And the point electrode forms a corona that spits electrons. And in the intense electric field directly under it, it forms a channel where you get lightning discharges and vortex winds. And on the outside, where the electric field is, the geometry of it it has less strength. That's where you get unipolar winds that pull up or blow down in downdrafts, and you also get electrical sputtering that causes EDM and eats away the material of the plate. Now, for those of you who are more interested in mythology, I've got a surprise. This is the Göbekli Tepe archaeological site in eastern Turkey. It's known as the oldest megalithic site that we know of today. Now, I know there's older megalithic sites elsewhere, like in Java, that are suspected to be much, much older than Göbekli Tepe. But this is the one that's consensus science has, said is at least 9,500 years old, 12,000 years ago. And that date's really significant for a couple of reasons. One, it's 6,000 years older than other megalithic sites like Stonehenge or the pyramids at Giza. So it has the archaeologists' undies in a bundy because they can't explain that 6,000-year gap and how Fred Flintstone and Barney could have done something like that. Now, what it's composed of is a bunch of rings that are oval or D-shaped rings. And in the center are two limestone T-pillars that are about 20 feet tall that face each other. They haven't excavated all of them, only, I think, 3 or 4. But they've surveyed the site, and they think there's as many as 19 or 20 of them. And around these D-shaped pillars, the ring is formed by smaller pillars, also T-shaped, that are embedded into the walls. And then there's benches and entryways and passages.
Okay. 90 seconds.
Okay. So this is one of the T-pillars inside that's called the vulture stone. So I'll be quick. This T-pillar basically displays everything I've been talking about. First of all, you have the Pratt instabilities, which would have precursed the storm. But then along the top, you have the coronal storm system itself. If you were looking at the Great Red Spot and you were seeing that colonnade of arches across the horizon, this is exactly what it would look like. The toroidal clouds would look like cylinders, and in a supersonic environment, they would be sharply edged features, and then you have the loops diving into the center of them. And below it, you have all this diagonal patterning. Well, these triangles down here represent the shock waves in a supersonic, dusty environment. If you think that's a stretch, let me show you this. This is an F-18 fighter jet flying at supersonic speeds, and it has a bow shock and a tail shock. And then in the thermal layers of air, there form all these chevrons from the compression and rarefaction of standing shock waves that form triangular features. And that's what I think we're seeing here. And across the center of it, there are these little boxes. And I think that's just a lenticular cloud that's been segmented, a lenticular cloud in the jet stream that's been segmented by the shock waves. Now below, I take this as ground level on the T, this dividing line. Below the ground, there comes a scorpion and a wolf and a salamander. Now I think that represents a ground arc, followed by the howling winds and the tidal wave. Wish I had a little more time, but I guess that concludes it.